Good afternoon, everyone. Thank you for joining me for another episode of Data Stories, where we explore the nexus between people and data. I'm Bahija Humphrey, and I'm the CEO of the Data Science Alliance. Today, we have a rather special conversation scheduled, and the sort of nexus of this came from my conversations with people about how data science exists in fields that they don't necessarily realize that it exists in. And you can find it in so many different verticals. And so one of the things I wanted to do was find someone that was a leader to speak to the data science work they're doing in one of my favorite fields, which is fashion. So I reached out to the very impressive Eric Colson, and he agreed to meet with us and share some rather interesting information and some algorithms with regard to his work at Stitch Fix. I would argue that Stitch Fix helped really bring forward the idea of data science innovating in a field that you would normally not even associate with data or science. And I think that they have proven that interesting things can happen, and they've revolutionized the field in many ways, and now are being replicated by some of the giants. So that being said, I just want to give you a quick couple minutes on Data Science Alliance, and then I'm going to introduce Eric and pass over the Zoom to him. So let me just share my screen really quickly. Let's see. Okay. And of course, we're having. Okay, we're having a little, hold on. There it is. Okay. And can you tell me if I'm sharing a presentation? Do you see us, Data Science Alliance? Okay, thank you. Okay, so the Data Science Alliance is a nonprofit. We are a member-based organization, and we encourage you to join us as a member. What we are is focused on advancing San Diego as a leader in data science here. And so 3 of the priorities we're focused on is problem solving, because anyone that knows anything about data science knows it's about solving problems. It's about business and connecting data science to more and more verticals and finding new opportunities for data science to be integrated in all sizes and all types of business, including startups. And then, of course, talent development. How do we continue our partnership with academia and encourage and foster the development of talent and really connect them to industry so that they're ready to go and ready to succeed when they graduate. We have several ways you can connect with us. So I encourage you to follow us on social media. And again, we are a member-based organization. You can look us up online, check out our website, and you have different opportunities that you can engage with us, including joining as a member and even volunteering. Today's discussion will be focused on the Stitch Fix story as told by Eric Colson and from a data perspective. And we'll have some Q&A, but in conversating with him earlier, he'd love to, if you have questions, go ahead and put them in the chat or in the Q&A, and you don't have to wait. And I'm happy to be the interrupter, and I'll jump in and ask your questions as we go along. So don't be shy. And so let me tell you about Eric. I want to read his impressive background. So Eric serves as Chief Algorithms Officer Emeritus of I have here the company, of Stitch Fix. From September 2009 to August 2012, Mr. Colson served as the Vice President of Data Science and Engineering at Netflix, a media company. From December 2006 to September 2009, Mr. Colson served in various roles of increasing responsibility on the data science and data engineering teams at Netflix. Prior to joining Netflix, Mr. Colson served in senior data science roles at Yahoo, a technology and media company, Blue Martini Software, a software and professional services provider, and Proxycom, a developer of interactive and internet-enabled solutions. Mr. Colson holds a BA in economics, shout out, so do I, from San Francisco State University, an MS in information systems from Golden Gate University, and an MS in management science and engineering from Stanford University. And we're very excited to have him as our guest. Welcome, Eric. Thank you for joining.
Thanks, Bahija. Hello, everyone. Give me a second while I share my screen. As Bahija mentioned, feel free to ask questions as we go. I'm going to lean on Bahija to tell me when there is a question, and also to keep me honest on time. I may ramble. So I'm going to share my screen. I have a little short presentation to give you and then walk you through this interactive visualization that you can also visit on your own after. Okay, can you all see my screen? Okay, sounds good. I'm going to go to presentation mode. Just to give you a little context on Stitch Fix, not everybody has heard of Stitch Fix, so we'll walk you through a little bit about what the company does, and then this leads into what makes it special with respect to data. So Stitch Fix is a personal styling company, so it's close, but very different. We rather than shop for them, we help you find them in a different way. So here's how it works. This is the nutshell version of it. So rather than shop around and search and filter and kind of guess on things, what you do is you create a style profile. You just tell us things that you like, what you're interested in, other information like size and height, that kind of stuff. And then we'll pick out things for you and send them to you right to your door, sight unseen. It's called a fix. You get 5 items. And you get to experience those items in the privacy of your own home. You can try them on with your own mirrors and your own shoes, all that kind of stuff. Then you decide what you like and what you don't like, and you can send anything you don't like back. You only pay for what you tell us that you're going to keep, and we take care of the shipping both ways. So that's that's how Stitch Fix was born, out of this kind of personal styling service where we spare you the effort of having to shop. More recently, we did add the ability for you to lightly browse around on your own and pick out stuff. This is still very different from traditional commerce, but more recently we added this, your personal shop. So once we know something about you, we can now recommend and let you pick out on the website before we ship it to you. So just a new twist in our model, but still very different from your traditional e-commerce experience. So I've been with the company now a little over 8 years, mostly from the beginning. In the very, very early days of Stitch Fix, I was introduced to the founder, Katrina Lake, and she kind of described what she wanted to set out and do. At the time, it was very small, very nascent. But my response was, wow, what a novel business model. I think officially the word I used was quirky, but novel sounds better. We'll go with that. But it was interesting. It's like, wow, this is pretty cool. This is like, you spare the customer all the labor that goes into shopping, and you're gonna have to be so confident in what you send the customer that you have to make sure they're gonna find something they like, because it's gonna be very expensive to ship it. So very novel, and I could anticipate the value to the consumer a little, but it was far more than just novel. It took me a little while before I realized what I was getting into. Like I was an advisor to the company before I joined as an employee. What I learned in that short time, it was just a matter of a few months as an advisor, was a few things. That first of all, this business model is symbiotic. What I mean is it's both the customer and the company have each other's interest in mind. Right, so a customer's coming fatigued with shopping online or in stores, and they say, "Can you do this for me?" And us, Stitch Fix, we say, "Yeah, we want to do that for you, but only provided that we can do a good job, right? Because it costs us a lot of money to ship this stuff, or if it's not working for you, it's not going to work for us either. And likewise for the client, if we're sending you stuff that you don't like, this isn't working. So we have what I call symbiotic. We both have good intentions and each other's best interest in mind. So that's very cool and very rare. Like you rarely see that type of copacetic relationship between company and customer. Second, it was good economics. It wasn't intuitive from the beginning. I thought, God, how is this going to work with a high cost of shipping? But it turns out it works out really well. We spare ourselves the same as e-commerce, expensive stores and real estate. We also spare, it's very efficient. We can go into that later. But the economics were much better, even better than we had anticipated originally. As Katrina had spec'd out the business model, it actually turned out it was better than we had estimated. And last, it's extensible. We started with women's, but we had expanded into men's and kids and plus sizes and maternity and petites. And now a few years ago, we went into the UK with the offering. So it's extendable so we can serve more and more clients. So far more than novel, but most importantly, the thing that even I, coming from a data background, even I underestimated was the power of the data. So this data that this new business model produces enables us to differentiate through data science. We're going to talk a lot more on that later, but just for now, suffice it to say that this data works magic, allows us to be much more efficient and serve our clients better. So in all this, in just a few years of this business model, so it was founded in 2011, in just 7 or 8 years, we were able to take it public in 2017. So it's pretty amazing that it not only did it work, but it worked very well. We only took $42 million in funding cumulatively. That's the total we took from VCs. And that company is now worth almost $4 billion. And that's pretty amazing. We were profitable since I believe 2014. So really a compelling business model. This worked out very well. And growing from just a few dozen clients when Katrina founded the company, it was really just validating the business model with a handful of clients. And then we're able to scale it up to now 3.5 million active clients. So very, I guess, almost unintuitively effective business model. Like I did not think it would be this big of a deal. Again, I lasted only 3 months as an advisor until I approached Katrina and says, if you'll have me, I think I'm in. I'll become an employee. I definitely had to learn that. She tried to tell me from the beginning, hey, no, we're going to change the way people shop. But I thought that was just founder aspiration. Turns out she knew what she was talking about. So very successful. And at the heart of this is data. So I'll talk a little bit about this data. What's different about our data versus e-commerce or a traditional brick and mortar store? So I'd like to divide data into 3 sets. There's more than that, but this is a decent simplification. So on the one side, this left side here, we're going to have client data, our customers. As I mentioned, they're coming to us mostly because they don't want to have to shop for themselves. They want us to provide that to them as a service. Now, it's pretty clear that if we're going to pick out clothes for you, you're going to have to tell us something about yourself. So there's a pretty lengthy questionnaire called a style profile that our clients go through. This is a much abridged version, mocked up, but we have things like height and your sizes, and then what price points you're looking for, et cetera. And then even like what brands you might like. All this is going to help us pick out clothes for you. So that all happens before we even engage with the client, before we ship him or her anything. It allows us to paint a very clear picture of our client. So this is a fictitious client here named Colin, but we know a lot about him already. Now, on the other side, the far right side, we collect a lot of data about our merchandise. We do buy and hold inventory. And as we do that, we do our own warehousing and all that stuff. This is so that we can control the experience. But another reason is so we can collect data on our merchandise. So we do have a little app. This is a mock-up of an internal app where we record a bunch of data about every single thing that we own and we put in our inventory. So we have a process at the office where models will try on our clothes that we're buying. And we take certain measurements. We record this information, like what brand is it and what price, and the dimensions of in this case, a shirt, even materials and other things that we're collecting. You can see how this allows us to make a very good picture of each piece of merchandise. And again, I'm hinting at this already. What we're trying to do is find out all the data that allows us to match clothes to people. So you can see, you might already be thinking about which attributes you might do that, to match this person to this shirt. The third set of data is right here in the middle. It's what happens when you expose the client to pieces of merchandise. So in this case, the shirt, but we can also expose them to lots of other things. And then we get his feedback on that. So that happens in a little form. Once we send it to the customer, he or she is going to fill out a form like this that tells us, first of all, are you going to keep this thing or not? But also, what do you think of the size, the price, the style, and the fit, right? All these things are super important that we need to know how this worked out for you. And that allows us to collect some very, very compelling data. This is where it gets very different from e-commerce or a brick and mortar store. So specifically, there's 3 novel properties to this data. Number one is that it forces a wider consideration set. So again, if you're receiving clothes that you did not pick out for yourself, it allows us to kind of expand your horizons, if you will, to pick out stuff and, hey, try this on. I know you would have never considered it on your own, but try it. We want to know what you think of it. So that's very interesting from a data science perspective. As you might know, that most data that you're going to study is biased by the data generation process, right? So if you look at data, if you looked at people's responses to clothes that they picked out from themselves, it's going to be very different from their responses to clothes that they didn't pick out, right? So we get to, and we hear this a lot from clients, hey, I would have never thought that this thing would be for me, but when you sent it to me, I tried it on and I loved it. So I like to say it gets us less biased data because it's not pre-filtered by the client themselves. And sometimes as consumers, we don't know what might be good for us. We need to kind of broaden our horizons to try more things. So that's one thing that this achieves. Another thing is we get feedback on both what works and what doesn't. So this is a stark contrast to, say, brick and mortar. In a brick and mortar store, there's certainly a record of something that somebody brought up to the cash register and they purchased, right? We have a record of that. And we can infer that they liked it because they bought it. But what happens when somebody takes something into a dressing room, they try it on, and they decide they don't like it? They put it back on the rack, and there's no record of that whatsoever. We don't even know, well, why didn't you like it? Was it the price, or maybe the fit, or the colors, or the materials? We need to know these things. And it turns out that's very valuable data. Even those so-called negative events, they didn't like it. We need to know about that. That helps tune our algorithms. So very important that we get this feedback both on what you like and even on what you don't like. And then finally, it's thoughtful. This is far better data that we're getting back than, say, rendering things in an app or on a web page where we're just inferring kind of passive behavior. Oh, well, they didn't click on it, they must not have liked it. So this is very different. We've put it in front of them, we put it in their house, and they've tried it on, stood in front of a mirror, and now they're giving us feedback on what they liked or didn't like about it. So very thoughtful data. So these 3 properties really change the game and enable us to do a lot more with it. And that's where the rest of this presentation, I'm going to jog over to this thing called the algorithms tour. And you can, after the presentation, you can take a look at this yourself. The URL is there, and we can probably send it out to you after as well. So I am going to, bear with me, click on the link and get there now. All right, does this look good to you? You guys can see this fine? If not, just give me a little signal. Okay, get a thumbs up. Okay, so this is a little interactive visualization that you can go through on your own. We put it out there, honestly, for recruiting efforts. It's not always obvious what type of interesting data science work we have to do at an apparel company. And so we thought we'd put this out there to entice people, say, wow, there is really cool work to do at Stitch Fix. So this is what we call the algorithms tour. You can scroll through it and read it at your leisure. I'm going to go through it at a rather brisk pace, skipping this intro, starting, I think, around here. So the navigation, by the way, on the left side, they're grayed out because I haven't clicked on them yet. There's 10 different algorithms that we're going to walk through. We may not cover them all. but you can click, each one is an autonomous unit, but there is a little bit of a story flow if you go through it linearly. So that's what I'm going to attempt to do again at a brisk pace. All right, so this starts out with, this is our client and she's interested in getting some clothes. So let's see, do I need to back up a little bit? All right, so again, a client. Here's some of the data I just talked about. This is that style profile where we're collecting all these client attributes. I apologize if you're not amenable to reading mathematical notation. This is very mathy. But we call this the customer vector. It's all this information we know about the customer. And again, we do the same thing on our merchandise. We call it the style vector. And that's initially what we have to work with until we get some feedback data. Now, one of the things that happens, the main point of this whole interactive visualization is to show the diversity of algorithms that we now have up and running throughout our company. Because a lot of people think of us as just a recommendation engine, and that is true, we do that, but we have over 100 and I think it's 35 data scientists now working at the company, and there's only a small number, say 7 or 8, that are working on the recommendation engine. The others are working on different algorithms. That's what this is meant to convey, is that the applications are quite diverse and they abound, and we have them in nearly every area of the company. So as this client signs up for Stitch Fix, she picks a date. But one of the very first algorithms to run is this warehouse assignment algorithm. So this is, if you can see that gray, that's the United States, and our client, there she is, she lives here somewhere in the middle of the country there. And we see various distribution centers, our warehouses, where we keep the clothes, and that's where we're going to be shipping the clothes to this customer from. Now, one of the interesting things is we need to intelligently assign her to a warehouse. Which one should we pick? Well, you might think, well, why not minimize shipping cost and pick the closest one? That's a decent strategy, but we care a little bit more about that. We have some other considerations. We care about another cost, which is, or you can think of it as a benefit if you flip it. We care about how good a match the inventory at any given warehouse is for our client, right? So if maybe she's very close to one warehouse, and that would minimize shipping costs, but if there's another one that's further away and there's a better chance for success, meaning better matches in that one, by all means, we're happy to pay the extra shipping and get her clothes from the further one. And there's other considerations in there too. So what we did is we built this kind of constrained optimization problem where we have a matrix of customers or clients going down here, going down the rows. Across the columns, we have warehouses. There's more than 3, but just an abridged version here. And in the body or in the contents of the matrix, we have a cost function. And what we're trying to do, so we can serve the client out of any of these warehouses with different costs. So what we're trying to do is set up an assignment matrix. So each client is assigned to exactly one warehouse, and every client gets assigned to a warehouse. So what we're trying to do is set up the optimal assignment matrix such that we minimize these costs. So there's an algorithm that does that, that figures out, hey, we have a bunch of clients to consider. How should we distribute them around the country to different warehouses, and while taking into account shipping costs as well as how good of a match is the inventory at that warehouse for them. So we have an algorithm for that. So in this case, it returns Texas for her. So she's going to be assigned to Texas. And now it comes time to pick out clothes for her. Now to do that, we have over here our 2 compute resources, 2 types of compute resources. We have machines on the bottom, and we have humans on the top. Humans are a type of compute resources. And the 2 do very different tasks, right? Machines are great at calculations. Humans are great at some other types of things like judgment or handling anomalies or fostering relationships, being able to empathize. And so we need both of those in our recommendations. So we want to leverage both of these compute resources. So we're going to start with the machines. And so what the machines do, among other things, is first there's something called qualification. We take all of our thousands and thousands of different distinct things that we could consider for our client, and we qualify them to her. Qualifying means we're eliminating some stuff. It may be super relevant in terms of price and style and texture and material, but maybe it's not her size. Then eliminate it. There's no point in considering it any further. Or perhaps it's something she's already purchased. Again, eliminate it. No point in considering it now. So that's called qualification. Those are really, better done by machines because it can be done very quickly and effortlessly. And then we run them through many different algorithms to assess how good of a match is this piece of merchandise to this client. And there's a number of different algorithms that some of this is a little out of date where we've evolved a little bit and we are using different types of algorithms, but I'll go through some of this anyways. So there's a lot of people come to my think quickly of collaborative filtering as a very famous type of algorithm for doing recommendations. And it's true, it works fairly well, but not great if you have a very sparse matrix like this, where we have, again, clients going down the rows here and across the columns are all the various things we could consider for each client. And there's millions of clients, tens of thousands of things, pieces of merchandise. So it makes a very big matrix and a very sparse one because clients aren't exposed to that many things. And so, yeah, you could try collaborative filtering. It hasn't proved super successful. For us, we use other methods. One thing, this is no longer in use, what we used to use something called mixed effects models that were very smart at the time because what we can do is leverage all those attributes that I mentioned. Apologize if you can hear a dog barking. I'm not going to be able to control that. It's one of his flaws. So bear with me on that one. So, but we have a lot of these, what we call them explicit client features. So again, earlier in the presentation, I showed things like height and weight and size preferences, price preferences. Those are things that we call explicit because the client told us explicitly, here's what I want to spend. And same thing over here on the style side. I mentioned all that data that we collect on every piece of merchandise. Those attributes are here. And those were super amenable to using things like mixed effects models. So we can put those all into our algorithm and they could be used to match stuff. Later, we evolved to derive what we call latent features, hidden, right? These are things that may be different from what the client told us. So for example, not everybody knows their size. They think they know their size, but there's no standards across the brands and sizing. So it's a common thing to get wrong. And so we have to derive a more accurate size that may be different from what the client told us. Same thing happens with style. It's very hard to express what your style is. And so we actually derive a version called latent style. And this is all done once we get more information, once we engage with a customer, we can derive a lot of these things. Same thing happens on the style side. We think we know this piece of merchandise and we learn as we go. And so now we have all these hidden features that we can throw into our model. I mentioned latent size. This is just the schematic of it. So when we use letter sizing, this is like extra small, small, medium, large. So here's an abridged version of that spectrum. But what we tried to depict here is that medium's a pretty wide spectrum. It really depends on the brand and other things. And that you could be on the kind of big side of medium or on the small side of medium. And likewise for the styles, they can run big or small. And so what we try to do is put each piece of merchandise and each client on a more specific point on this spectrum. And you're looking for very short, in this case, vertical lines to match them, right? Long horizontal lines would not be a good match. And so you can calculate those distance and then and put this into your algorithm to more accurately match clothing to clients. All right, we'll keep moving here. Image processing. So this is something we used to do. We've now evolved this a little bit more, but this is back when we were using these deep neural networks, convolutional neural networks to read in what customers pin for us on their pin board. So a lot of our clients use Pinterest to pin things. We have now introduced something new called a fixed inspiration board where clients can directly add images of things as examples of stuff they like. It's very hard to express in words what you like. It's really hard to write in text what you're looking for, but you can just pin a picture and say, yeah, things like that. And so what we did is we trained a neural network to read in those images and then recommend stuff similar in our inventory. Another deep learning example is using or processing text or natural language processing. So our clients write us little notes like this one. It says, I need something to wear to a casual outdoor wedding. And we will process that using algorithms to help recommend stuff up. Now our stylists will also read the note, and frankly, I think they do. They're more reliable in getting the context out of notes than even our best natural language processing algorithms at this point. But we do use both, and the two combined, we're hoping are better than either one alone. So again, machines using natural language processing, a whole bunch of other algorithms. The final result is they rank order everything that we could possibly send a client, and they send that over to our next processor, which is a human, because we want to not just do all the things that machines are great at, but we also want to layer in human abilities as well. Now, unlike machines, which are homogeneous, we humans tend to be more heterogeneous, meaning they have differences. So we want to pick not just arbitrarily like we did with the machines, but we want to pick, I'm backing up, here we go. We want to pick the best human stylist for this particular client, right? A stylist that would be a great match for this particular client. And so we look through all the stylists and we have an algorithm that runs, and we'll, this is going to look a little similar to the warehouse assignment algorithm. Here our matrix is a little different. We have a matrix of clients and stylists, and again, as sort of you can think of it as a match in here. Yet we have to assign them in an optimal way. So we have another constrained optimization problem where we optimize the way we're pairing up clients with stylists. And there's lots of different features to consider. One of the more interesting ones was, do they share a similar style or aesthetic preferences? And it turns out when you match those up, they do better together. And you also have to observe other things like constraints. Stylists can only take on so many clients, and so you have to make sure that you're allocating appropriately. So there's another algorithm for doing the client to stylist matching. All right, so we picked this stylist here, and now we're going to turn over that ranked the results from the machines over to our stylist, and he's going to look through this. We had a small group that was working on what we call human computation, how to make interfaces that improve the judgment of our human stylist. So there's a lot of information, and we don't want to overload a stylist. We have to make sure if we're going to put something on this page that it helps their judgment, or is it neutral? Because even a neutral might have a cost, and certainly we don't want put any information that impairs their judgment. So we had a team called Human Computation that would work on such things. And again, this role of the stylist is more than just their fashion prowess and their judgment, but there's certain things that only humans can do, such as empathize with a client, make sure they're getting the context of that note, and build a relationship. So our stylists, they will write a little note back. In this case, the stylist says, have fun at that wedding. Since it's outdoors, be sure to layer. All right, and so it's nice. It's building a relationship. It's acknowledging what the client was asking for and writing a coherent note back. And so now we have our clothes picked out. We know which warehouse we're executing out of. We have the notes written, and now it's time for fulfillment. We're going to send that information off to our warehouses, where we're going to do the pick, pack, and ship process. Right now, we have pretty vast warehouses. They're pretty large, and our associates were walking many, many miles a day to go around and pick this stuff. We do have some automation equipment now that we're using, but it's still a big deal to make sure these walking paths are not too long. So we have an algorithm that'll help map it out for them. What's the minimum path I can do? And which things should I pick at the same time when I'm going out on a batch? Which things happen to be close together so I can grab them all at once so I don't have to backtrack a lot? So we have algorithms that help guide our associates in the warehouse. Now, once we have our 5 things physicalized, we can ship them to our client. So that's our client down there. And there goes the 5 things plus a note. Our client looks at the note. She inspects the 5 items, meaning she's trying them on and seeing how they fit her, that kind of stuff. And then she decides. So in this case, you can see the 3 items going into her closet and 2 items going back to our warehouses, which is fine. We don't expect people to keep everything. But happy she found 3 things she loved. And that little, I'm going back and forth here, see that little green dot that's going off to the right? That's feedback. So this is our bread and butter. We need this feedback data. She tells us what she thinks of each item, even the ones she sent back. We didn't know, what did you think of the price, the size, the fit, the style, all that kind of stuff. So that goes back, and then the cycle repeats. She'll get another shipment at some point, and we can learn even more. And it's a nice data feedback cycle. And it doesn't just happen on one client, but on the aggregate of them. All the clients are doing this, and so it's a big high frequency events, a lot of data that we get to process back and forth. And each time we go around this data feedback loop, we get stronger and stronger. We can improve the algorithms more and more. All right, let me check time here. We're gonna keep going a little bit, and then I'm gonna try to get through this to get to questions. We're okay on time? Thank you. Okay, let me back up. Another interesting algorithm we have is kind of developing the state engine, as we call it. So this is supposed to be the same client at 3 different states over her lifetime with us, right? So maybe a client comes to us and they have a mostly empty closet and she's excited to start. I'm tired of shopping. I want you to help me with this. As she gets more and more clothes, maybe she gets more specifics in her request. So remember I mentioned the outdoor casual wedding, right? She's saying, oh, that's a very particular need, and she's relying on us for that. And then maybe at some point, this could happen. It's like, God, I got enough clothes. I'm pretty good for now. And so we need to know in which state the client is. In this case, there's just 3, but we need to know these 3 different states. Why? Because it matters on how we interact with them. A client that's in this state is probably not interested in getting a lot more shipments at the moment. A client in this early state here, well, she's probably interested, she needs more stuff. So we need to be able to anticipate this so that we can serve them better. So we have an algorithm that derives these different states. We start with like a time series type of data, and we do some calculations to classify them into different states. And you can flip states, right? You can go from this kind of greenish yellow state to an orange state over time to a blue state, then back to the orange state, etc. So here's what it looks like for a handful of clients. They're moving between different states, state 1, 2, and 3. And we need to calculate these transition probabilities. So we're using something akin to Markov chains here, where you can move from one to the other. And again, what do we do with this data? Well, it allows us to predict, roll things forward. We can roll time forward to see in whatever 4 or 5 months, 6 months, 10 months, a year, how many clients will be in each state. That's what's being calculated here. So we're saying this many clients will be in that bluish color, how many in the orange color, and how many in this greenish yellow color. Each one has their own probability of needing clothes. And so we multiply the probabilities by the states, and you can derive this, a demand for shipments. So this is super important to the company. It allows us to make a lot of good decisions. One of the biggest is, how much inventory are we going to need, right? If we can forecast the number of shipment requests that we get, then we know how much inventory we're going to need. Moving forward, we're moving into a lot of the merchandising algorithm space. So I just mentioned about how much inventory we need. Then we get a little more specific about which types and how much of each. So this is an algorithm right out of operations research literature. It's called QT algorithms, where we, this teal blouse, you can see them coming in, being dumped in there. We can forecast how many we need over, say, a season. And that total amount that we need over the season, we don't want to just buy it all up front, because that's not super efficient with the capital. Instead, you want to stagger the purchases like this. You want to buy some, let it deplete, not go to 0, but let it deplete, and then buy more, and then let it deplete, and then buy more. This is a far more efficient way to do your purchasing. And there's a little bit of the conceptual framing for that algorithm down here. But you can see how we never let this hit 0, it'll bounce back up before it hits 0. And so there's an algorithm that manages this replenishment. There's also another algorithm called allocation. We have different warehouses here, we're showing 5, and we need to spread out that purchase amount to 5 different warehouses, right? You can do it arbitrarily or by percents, but that won't be very accurate. What's better is if you take into account the local demand and the local supply, that how much they already have of it. That allows you to do a much better job of getting this stuff out to the right areas of the country where it's going to be needed the most. So there's an algorithm that does the allocation. There's also a little algorithm that will, when things are no longer relevant, it pulls them out of circulation. We used to donate them. We're doing some other things with them now, but that's done by an algorithm. It says it's time for this thing to be retired. Let's keep going here. Finally, there's second to last one here. There's another algorithm. We talked a lot about merchandise algorithms. And again, most of our merchandise is other vendors that we buy from them and hold in our inventory. We do have a dozen or so of our own brands that we actually produce the clothing for. And for this is a little out of date too. We have now evolved this, but we used an algorithm to design our own clothes. And the way this worked was we would take a blouse, this one, and we'd decompose it into its elements. So that's a neckline, there's a sleeve type, there's a pattern, a color, some dimensions, and some other metrics, etc. And we can decompose that, and plus everything we know about it, how it did with different groups of people. And we can do that for all of our garments. And we can find some, we can ideally quantify each element independently of each other and then recombine it in new ways and add some random mutations if we feel like to try taking some risks. And we can come up with new clothing that has never existed before. And it did quite well for us. So this was started as a little pet project by somebody, and it really worked well. We ended up producing a couple hundred new designs that did very well for us. So very impressed. Even I was not that confident in an algorithm's ability to design clothes, but it did well. So lastly, I wanted to preface all of this, that this all has to run on a data platform. And this is, we have a team called the Algorithms Platform. And sorry, I'm having a little time getting this render. Let's see. So data scientists are obviously highly skilled and adept, but they may not all be computer scientists. Now, so what we do is we use the Algorithms Platform team to help abstract them from some stuff. So this is our data scientist up here. And you can see she's using high level primitives or code, like you can just say load data and provide some parameters. You can say train model and provide some parameters. So she doesn't have to know all the guts and innards of our infrastructure. So we have a team, a subset of the algorithms team, is called Algorithms Platform, that works on the platform. And I'll replay this again. So some of the things that you get abstracted from if you're a data science is data distribution. You get the data gets spread out for you. You saw new nodes added dynamically as it detected it was needed. You see one node catches on fire, it automatically moves the job over to a new instance so that the thing can keep running. And so all of this is very nice, keeps the data scientists focused on science and not having to worry about the innards of the infrastructure, which can get quite nuanced. So big nod to our algorithms platform team. They provide a huge service for the data scientist. And with that, I think I can wrap this up. I'm going to head back over to the presentation just to put up my questions slide, and we can move on to questions. I think we're on good time.
That was quite impressive and fun to watch. Thank you, Eric. That was super helpful. So I have one question that came in so far from Kayla, who asks, how has Stitch Fix's model evolved during the pandemic?
Oh, good question. Some of which I probably can't share, but I can. There's a few things that we have already published in an article, so fair game there. As you might imagine, with the pandemic, preferences changed. People no longer going to an office. They wanted more casual, more comfortable things, and we definitely saw that the demand for that shoot up. That was one interesting thing, and of course, we had to stock up on that stuff because we didn't. We forecast things before we had knowledge of the impact of COVID, and we had to scramble to get more casual things into our inventory as soon as we could detect that. Another interesting story was the demand for golf type of clothes has gone way up. Golf being a reasonably safe sport to engage in with social distancing, and so it makes sense to me. Even it resonated because even my wife wanted to start taking golf lessons to do something during the pandemic. So yes, there has been some change, and we do see some more consumers are moving online to do their shopping because it's maybe either not safe to go to stores or they're not open. And so we have flood of new clients coming in that we need to help serve. So there has been some adjustments made to during COVID.
Okay, great. And just a quick follow-up. How quick is your turnaround to pivot with something like that? It sounds like you were able to pivot rather quickly, but I don't want to assume. So tell us about sort of how, not just during a pandemic, but in general, when suddenly you see trends moving in a different direction, how long does that take for you guys to pivot?
Yeah, another good question. So clothes being physical, it's not immediate, right? They have to be sewn. It's a little bit all over the map. It's vendor by vendor how fast their turnaround time could be. If we call a vendor, say we need more of those, sometimes they can do it very fast. Other times it's quite slow, where there's literally stitching time or shipping time that can take a while. So the industry is not as efficient as other things where things are readily available on hand. It does take some time, and it's really anywhere from weeks to months, depending on the specific vendor. And so we can respond faster in some cases than other things. We do have to wait.
Okay. A question from Veronica. Do you have an algorithm for pricing?
Good question. No, we don't. We have a fairly standard practice for pricing. That's the standard markups. We don't do any more or less than most other retailers. One thing we don't really do is sales, though. We're a full price model, differentiating more so on the service and the relevance of the stuff we put in your hands than we do on like discounting, right? It's not what we're about. So we don't have a lot of dynamic pricing that's happening, things like that. We've studied stuff. We do, what we do is derive each client's sort of price preferences. Remember I mentioned they tell us explicitly what they want to pay, and sometimes their behaviors suggest otherwise. And so what we want to do is make sure what we have a latent, again, latent meaning hidden, price preference. So there's what they tell us, and then what they actually do. So some clients are a little bit different from what they said in either direction. And we certainly wouldn't want to deprive a client. So suppose a client said, I'll never pay more than $100 for a pair of jeans. But we have like the perfect fitting pair of jeans that happens to be like $110. We would be able to calculate, is that going to be a deal breaker, or should we actually send it to them? And we found that if everything fits perfectly and the texture's right and the stretch and all that stuff, that the extra $10 or $15 is fine. And we do that individually for every single client. We'll find their true preferences on that elasticity curve. So we don't do a lot of other experimentation on dynamic pricing. It's more on what are your actual preferences.
Wow, okay. And then Colin's question, which speaks to my heart, because my jaw dropped when you said 135 data scientists. Our audience is nerding out on this, so it's great. My question, Colin says, is 135 data scientists. Wow, how do you all manage that? I guess he's wondering mostly about the social side, like how do you decide what to work on? When is it good enough to ship? It's quite a large team.
It is. If you're interested in more of the way we work, there's another very fun visualization, very similar to the one I showed you. It's called Cultivating Algorithms. If I'm still sharing my screen, I could at least render it for you. You guys are still looking at it. Yes, you are. All right, you go to Cultivating Algos at stitchfix.com, and you'll see.
Oh, cool.
Another one that you can scroll through, and it walks you through a lot of the same type of concepts, but more about how we work. Here, I'm going to stop sharing so I don't waste. These things are very CPU intensive, by the way. They will drain your battery. Yeah, make it back to there. But yes, you can learn more at cultivatingalgorithms.stitchfix.com on how we work, how the data scientists do things. I can reveal a few of the things that you'll find in there. A lot of it is bottoms up. We do have a lot of company initiatives that we help support, but a lot of the ideas come from the data scientists themselves, because they're swimming around the data and they have some esoteric knowledge, and they're not things that we would, we as managers or executives would even think to ask of, and it comes from them, which is really quite amazing.
I love that, because it's the data coming back, and you're getting more gains out of that. Okay, we're in kind of light of the time. I do want to ask you, where does it go from here? Like you've fashion pre-Stitch Fix versus post is so different, right? But I think there's a lot more, and we can go even further. And not necessarily Stitch Fix, but you, from your experience and drawing from Netflix and all your background, where do you think fashion goes from here, from a data perspective, and how do you see it changing?
Good question. I mean, I think, the consumer behavior has already begun to change to expect personalization. The days may be nearing an end where we used to have to wander around on our own to find stuff, like either, again, through web page browsers or in a store, where there's nothing personal about it. I'm on my own to go wander around the store to find out what is right for me. A good image or way to think about it is, remember those scenes from the movie The Matrix where there's racks, I think there were guns, but racks and racks of guns, and then they all disappear except for the ones they wanted, right? And that's how I think about it. You walk into a department store and imagine everything disappears except for the stuff that's relevant to you, and it makes life much easier. And I think that expectation has already been, planted in the heads of consumers, that they like, why make me work for it? You're supposed to do this for me. You show me what's relevant to me, and I just need to do the easy part of decide if I like it. But it's kind of like, I don't know if you're familiar with Kahneman, his thinking fast and slow analogy, where there's two types of thinking. One is the tough, where you have to calculate things and really think through things. The other is more of a snap judgment. Do I like this thing? And it's getting rid of the type 1 and moving just to type 2 decision making. Do I like this? And that's all you have to do. You don't have to go search around, know your size in each brand, all that kind of stuff.
So great. Okay, thank you so much, Eric. We really appreciate you spending time with us and sharing quite an interesting and beautiful visual for us, and walking us through the story of Stitch Fix and how sort of the behind the scenes, which was fascinating. I really appreciate you spending the time with us, and thank you to all the attendees. We hope you enjoyed the conversation as much as I did, and we'll see you next time. Thank you so much.
Thank you very much. Take care.